Particle is moving along the line OX, so basically that means the x-axis, with a constant acceleration equal to a, where a is a positive constant. When t equals 0, the particle is at 0, so what we're being given there is x is equal to 0 when t equals 0. And we're also being given that the velocity is u when t equals 0 in the direction OX, which means, again, going along the positive x-axis, so u is a positive constant. We want to find v and x as functions of t. So v is going to be the integral of a dt, and of course a is a constant, so that's just going to be at plus a constant which I'll call c1. And we know that v equals u when t equals 0, so substituting those in, u is equal to c1, and therefore v is equal to at plus u, or u plus at, as you're probably more used to seeing it. And it's one of the equations you've probably met in physics. So now x is going to be the integral of u plus at dt. Well, u is just a constant, so we get ut. And then we have at squared over 2 and a constant. But we know that x is equal to 0 when t equals 0. And that should tell us, I should have called it C2, that the constant 2 is 0. And therefore x is equal to ut plus at squared over 2, which you could write as a half at squared. And again, that's an equation that you might recognize from physics.